This question is related to the turning effect. The diagram shows the minimum force F1 acting vertically on a lever required to lift a heavy log of a weight W. So the log need to be lifted by a smaller force. I want to apply a smaller force. Because what is the concept here? Simple concept, like there's a turning effect, an anti-clockwise turning effect due to caused by the weight of the log, and that is to overcome this, we have to apply a force to lift this log. So we want a minimum value of, in the question, the log need to be lifted by a smaller force than F1. Like we want a smaller force. The diagram shows a change tried. Each diagram has only one change from the original. And in each case, F2 is the minimum force we required. Look, if I use the numbers here, like give an idea, if this is, let's say this is causing a moment of a 30 Newton meter, this is also causing a moment of a 30 Newton meter. So the minimum, like to hold it, and we need a moment more than 30 Newton meter. But now, as you can see, this causes a turning effect, but here the distance from the pivot is more. So if the distance of the pivot is more, so F1 should be less to cause the same turning effect. Because like if I use it, if I need a 30 Newton meter to lift this up, because the distance is greater, so as a result, the distance is greater. So the value of F2 will be smaller. Why? Because we want the same turning effect, minimum. So means in this case, for diagram P, the F2 will be smaller than F1. How we identify? Because this distance was greater, this distance was shorter. So F1 should be more so that we can lift it up. Here the distance is greater, so the F2 should be smaller so we can easily lift it up. So in this case, the F2 will be smaller. What about here? When you compare the force which is acting, the distance appear to be same. These distances appear to be same, everything. But here F1 was making certain angle. Here F2 is directly perpendicular. So when force is perpendicular, because if F1 is making certain angle, so we need a greater force because the perpendicular force makes it much more easy to lift an object. Here F2 is acting perpendicular. So the value of F2 will be smaller than F1. The turning effect, because the moment is a product of force and distance. The force should be perpendicular to the distance till the point of action of the force, so that we can easily do a turning effect or cause a turning effect. So here the force is perpendicular, so we need a smaller force. But here the force is not perpendicular, so we need the greater force. So in this case also the F2 will be less than F1. Here also F2 was less than F1. So P and Q till now, P and Q. What about R? For R, you can see they increase this distance. So if we increase this distance, we have to do a greater amount of turning effect. So we have to, and even this distance gets shorter. If the distance gets shorter, the F2 should be greater than F1. So the question is, in which situations F2 smaller than F1? So in case of P and Q, the F2 will be smaller than F1. But in R, the F2 should be greater because the log is further from the pivot, a point of rotation, and the distance between the force F2 and the pivot is also shorter. So the F2 should also be greater. Is it clear?